Today I'd like to talk about how you can become a full stack reverse engineer in only 3 short years. This video is a roadmap of becoming capable of working at any level of abstraction in software. You're not going to come out of this an expert in any field, let alone all the fields that are covered here. What it will do is give you the foundation to achieving that. This will put you in the top 1% of reversers and give you a trivial route to getting to the top 1% of security folks. This isn't a guide with a bunch of stuff to reverse engineer. In fact, pretty much none of this is actually reversing, because 99.9% of reversing is understanding various layers of abstraction and how they stack on each other. This isn't a direct path. It winds and meanders and goes off on tangents by design. Think of this like a breadth-first search of topics that are important to reversing. With that said, let's get the caveats out of the way. This is based on the trajectory I followed and have helped others to follow. It wasn't really planned out, and it almost certainly isn't the absolute optimal route, and it probably won't work for every single hacker out there. Take this all with a grain of salt. I know a lot, having done this for going on 20 years, but I damn sure don't know everything. This schedule is, at best, an estimate. In fact, call it clickbait and pretty much dismiss the timeline. This could be done in a year, it could be done in 10, who knows. Ignore the gimmick and just roll with it. And finally, this isn't all necessary for everyone. Many of the suggestions I make here are almost certainly going to start flame wars on Twitter because they're contested topics. I don't even 100% agree with everything here, and I wrote it. Don't take this as gospel. Feel free to skip things, reorder them, dive deeper into things that interest you. Think of it like a survey class for breakerdom. And last but not least, before we get into the fun stuff, let's talk about prerequisites. Technically, there are none, but that's kind of nonsense. Everyone is going to come at this with a different level of experience, and for some this stuff will come naturally. If you've already taken an OS course in school, the kernel dev exercises will take you a couple weeks at most. If you've been doing this stuff professionally for years, this will take you 20 minutes. But what's really important is that if you run into a wall, just go with it. Go learn something new and come back to this a little older and a bit wiser. Alright, let's jump in and talk about year 1. First things first, read the book Reversing by Eldad Eliam, whose name I'm certain to have butchered. This isn't the perfect book, but it is a good jumping off point. You'll learn the basics of reverse engineering code, reversing file formats, how copy protection works, important tools, etc. However, don't feel you need to read this cover to cover. It's worth the money in a few hours skimming it, but that's really all you need. Refer to it if you get stuck, but recognize that it's now pretty damn old, and most of the information just isn't up to date anymore. Next, learn assembly for at least one architecture. First bit of flame bait. x86 is actually a good place to start. This is the architecture that ran most PCs up until the late 2000s, and it is still crazy prevalent. Your system probably still runs x86 code. It's also terrible. If nothing else, it'll be applicable to many tasks, and it'll make you cry tears of joy when you start doing assembly for architectures that don't suck quite so much. For what it's worth, that's pretty much everything but x86, but seriously, start there. To learn it, write some C code, compile it, and then hand decompile that from disassembly. Then have your friend write and compile some code, and have them check your work after you decompile that. Keep repeating that with more and more complex code. Don't forget to learn about floating point and vector code. Reverse engineer a game. This will teach you a lot about many different areas of reversing and computing in general. Start by picking a 3D game from the late 90s to mid 2000s, one that's running on a custom engine is key, because you want to hack something that grew organically and had little to no design or logic behind it. As a related aside, I'm currently building an open source EverQuest client, and we still have a ton of reversing to do because of exactly this. Feel free to join up, just message me on Twitter to help. With that plug out of the way, once you've picked a game, reverse engineer its archive format and then write an unpacker for that. Then reverse out its model format or formats and write a renderer so you can see them in all of their original glory. For bonus points, write it against OpenGL or WebGL to start, then port it to Vulkan. I can't stress enough how important understanding 3D APIs is. It'll come in handy in so many ways in the future. Read the Dragon Book, also known as Compilers. This is not a great book. There are better ones out there, but I haven't read them myself, so I won't recommend them directly. This will provide the basic knowledge of how compilers and runtimes work, though. how they lex and parse code, how type systems work, at least the limited ones that are in this book, how to generate code, and more. Feel free to swap this book out for any other on the subject. I promise I won't be offended. Then write your first compiler. Specifically, you should write a compiler from one high-level language to another. This is commonly known by the nonsensical term transpiler, which we're not going to use in this because it's utterly meaningless. I suggest starting with a language like Scheme, some fourth dialect, or Python, and compiling to the likes of JavaScript, Python, or Ruby. Consider also making your own source language. It's a lot of fun and it teaches you a lot. For bonus points, make your compiler have multiple different targets and make the same code run on all of them. Then write an assembler. This isn't actually that valuable an exercise, but it's easy and it doesn't take long, and one day you'll be thankful that you did it. Do not choose x86 for this. You'll spend 100 times the time and effort and learn exactly the same things you would if you did 6502, MIPS, 32-bit ARM, CIL, or literally any other architecture. Don't go with x86 for this. On to year 2. Alright, we're going to start off with probably the hardest thing on this list. You'll thank me for this later, but for now, you're going to write a compiler from some language down to the target architecture of your choice. I strongly recommend starting with some subset of C. Compiling the full language is bonkers, so don't do that. Just pick a subset. What target you pick doesn't matter much, but you should pick something you can run on hardware and not a VM. You'll learn a lot more. Once you're done cursing my name for that project, I strongly recommend reading the paper Reverse Compilation Techniques by Cifuentes. It's old and could use some updating, but it's still the Bible for decompiler development. This will put you in a really good place for future reverse engineering and tool development. Once you've read that, write a decompiler for either Android's Dalvik bytecode or .NET CIL. They're both easy to understand and they pretty much map one-to-one with their respective source languages. This makes them optimal for a first decompiler. I suggest doing this in 3 parts. Start by just omitting a bunch of code with gotos, then start reconstructing control flow, then go to SSA form and optimize and clean up the code. Frankly, this is the most fun thing on the list to me, but that's probably just me. Now write a decompiler for machine code. This is a completely different beast than what you just did because the languages typically don't map well onto the architecture. You need to infer way more from the code than you did in the previous project, and it changes the game. So pick an architecture, ARM and MIPS are good options, and decompile that back to pseudo-C. x86 is a terrible option, which I halfway recommend. It'll take you longer, it'll be way more difficult, but you'll probably learn a lot more. Alright, now go read the OSDev wiki until your eyes bleed. This seriously contains the best references for basically every low-level detail you can imagine. If it relates to kernels or operating systems in any way, it's probably covered. I've been doing this for ages, and I can go there and learn a dozen things in an hour of reading the wiki. And with that out of the way, write your first toy kernel. This might be the most alien thing on the list because it's simply so different than everything else you have done or will do in this. But you'll learn a lot and probably have some fun. Make a bootable kernel that will display some text, take input from the keyboard, and if you're feeling ambitious, display some basic graphics. Do it in C targeting x86 in protected mode. This is by far the most well-documented path and it'll get you started. This should not be a 2-month project. Think closer to a week or 3. Keep it simple. Now go read the OSDev wiki until your eyes bleed again. Then rewrite your kernel. You know you made some horrible mistakes and you're kicking yourself for them. Go fix those. While you're at it, if you have another language in mind for kernel dev, now's a good time to try that out. Rust is a lot of fun for this, for instance. Then port it to another architecture while keeping the code base shared as much as possible. Porting a kernel is really easy if you entirely throw away support for other platforms. It's a lot more difficult if you have to maintain both. Finally, write a microkernel. You probably wrote a monolithic mess of fail, and it probably didn't even support separate processes. This is the exact opposite. I suggest writing a microkernel inspired by L4 to start off, and if you want to go for a more adventurous route, try writing this in straight assembly or something like Rust. No matter what you choose, this is going to be a purposefully tiny project. Positively micro, in fact. On to year 3. We're on the home stretch now. Game system emulators really let you put all the pieces together in a big way. Let's start at the simple end of the spectrum though, by developing an interpreted emulator for a well-known platform like the NES, SNES, Game Boy, or PlayStation. Your goal should be simplicity and getting something working, not making it fast. Now we can mix in your compiler development experience. Recompilers are fun and very few people actually work on them. Time to become one of those people. Either build a new emulator or upgrade your existing emulator to use recompilation in place of or in addition to interpretation. I do recommend sticking with a well-known platform for this project though, because you're already going to have enough challenges doing the recompiler. And the last and biggest project of this roadmap, write an emulator for a partially or mostly unknown platform. There aren't many of them anymore, but they do still exist. One route is to pick up something like a VTech handheld toy for kids and pull the code off of that, then write an emulator for it. The basic loop is read everything available, start writing code and testing, then read all the assembly you can get your hands on, then repeat. It'll take you a while to put the pieces together and to track down bugs, but this will most likely teach you more than any other project in this roadmap. In fact, I would argue that emulator development is the single most effective way of learning to reverse engineer, but I'm sure that many would disagree with me. Regardless, if you complete even half of the things on this roadmap, you're already in a fantastic place and should feel very proud of yourself. This isn't the optimal list, as I said at the top of the video, but it's definitely going to put you in the upper echelon of hackers. I hope you enjoyed this, and thank you for watching. Good luck, happy hacking.